Hi everybody, my name's John Lanko. I'm going to do a talk on digital forensics using EnCase version 6. So who am I? Like I just said, I'm John Lanko. I work at the SRA SOC as a cybersecurity analyst. I like to click a lot of buttons, and as a result of those buttons I often will hit Control-Z shortly thereafter. Generally, my day-to-day, I'm working on malware analysis, network intrusions, and forensic analysis. So this talk will be a focus on the forensic aspect of that. So when we do a forensic analysis of a system, what kind of things we're looking for? Generally, when I do it, it's internal for the corporation. So I will focus on stuff like malware, evidence of intrusions on systems, employee no-nos if they're doing things they're not supposed to be doing on their systems. Sometimes we're looking for crime. And sometimes we have to help out the e-discovery team looking for documents for litigation support and that type of thing. So the tool, like we said, is EnCase. It's specifically for looking at static analysis of offline devices. So we're looking at basically hard drives that have been removed from the system. They're not running. We can see what happened, basically history of the system, not what's running this particular second. Some alternatives out there. FTK is a forensic toolkit. It's another tool I used a little bit in grad school, but we don't actually use it at my organization, so I don't have a lot of hands-on experience with it. SIFT is another one. That is a Linux distribution that you can get from the SANS Institute. It's related to some of the courses that they offer, and it's basically full of a lot of open source tools. So if you're going to go to a courtroom for some reason to display this evidence, they often like it when you have vetted stuff like EnCase and FTK. But I don't really do that most of the time. We're pretty much just looking for information, and that's all we need to know. So open source tools can get you a lot of leg up and can validate what you see in EnCase or other tools, things like that. As for this particular presentation, I'm not really going to show you how to do things in EnCase. That's kind of boring. I'm going to show you more what it can do and just give you a little bit of a taste of what kind of things we look for if we're doing analysis on a system. So the process that we go through when we get a case to look at is, first we have to somehow obtain that drive. Usually we just ask local tech support, hey, get us that. We might go get it ourselves, something along those lines. We make a forensic image of it. We have a special tool for that called the dossier. We also have a Talon, basically same thing. One's bigger than the other, that's a dimensional difference. And we make an image of that on another separate hard drive. Once we're doing all this, we also want to document everything we're doing. Just in case it does come up later on in some kind of litigation or the lawyers get involved, they like everything to be documented and say exactly what you did when. So even if you don't expect it to be involved in anything like that, it's always a good idea just to keep it documented just in case. We also like to make a hash of the drive itself. Once you make the image, you can make a hash. You'll have that MD5 hash to store it, and this way you'll know when you get your image, you can verify this is the same. What I copied is the same thing that I copied it from. Nothing was lost in the process. And later on, months later, you can also show that the drive I've been working on this whole time is still the same hash that I had from the original one that I obtained from the end user.
What about hash collisions?
It's extremely rare. It's like possible in lab environments. But even 1 bit will change the hash value. So generally, legally speaking, most courts will accept MD5 hashes without any real concern, at least what I heard. Yes?
I mean, with hash collisions, that's just taking the assumption that, you know, data accidentally got misplaced like 1 bit, not a malice player that actually thinks to replace the data with something that will meet the MD5 sum.
I think that the dossier that we actually use for taking images actually calculates 2 hashes, MD5 and an SHA.
It does.
So I think that will resolve a condition of a hash collision on a weak hashing algorithm like MD5 by having a secondary hashing algorithm. I mean, it would probably be astronomical to actually calculate 2.
And so far, I haven't seen anybody with a proof of concept technique to make 2 files that match on both.
Yeah.
Mm-hmm.
That'd be kind of awesome, actually.
Yeah, so we use MD5. I know it's not the best, but it is the easiest, and it's pretty much everywhere, so it works for our purposes. So when we're looking...
On the right blocker, hardware,
yes.
software, any preference there?
Hardware is usually better. Just because I don't trust software the same way I trust hardware. If there's a physical device there between you and the drive that you know doesn't have the ability to write to it, that's just going to be a lot better feeling than software-based. So the interface of what EnCase looks like, I don't know if any of you have seen it, but it's pretty busy. A lot of things going on here with EnCase. Just to give you a quick demo of what's going on, right here is the tree pane. This is basically what you're looking at. If you're looking at a file system, it'll show you what's going on. Hopefully you can see that there's a little green home plate next to the RIC folder. Well, basically all that does is that this is one of the harder things to learn. It took me a while to figure this out, but what that basically means is that now in the next pane I show you is a table pane. It's going to be able to show you everything in the RIC folder and everything that's a subfolder of that. So I don't have to go through and click through every single one of these folders to see what's going on. I just want to know everything that's a RIC or in the RIC subfolders. So this is where you see the results of what was in the tree pane. This is the table pane. This shows you all the files and all the folders that we had from the tree pane from before. So it's just a one way to navigate around a system. Once we have something selected in the table pane, it'll highlight down here and we'll see the data of the file in the view pane. And we can see this, EnCase shows you this in hex format or text format. It can try to represent simple stuff like pictures and basic Word documents, that kind of thing. For anything more advanced than that, you can basically link it to other programs on your computer. Say, if you see a PDF document and you can't open it, this is where I keep the Adobe Acrobat Reader or Reader Writer. So it can interface with other stuff on your computer as well. The last one here is the NScript pane. This is where you keep things that are called NScripts, which are basically there's a little language that EnCase has that you can build and roll your own scripts to perform more advanced functions and that kind of thing. Also, you can look through data and want to manipulate how you're looking at it. So you might have conditions or filters and other kinds of things that can hide all the stuff you don't really want to see. This is where you'd play with that kind of thing. And the last place is down here at the bottom. I'm not sure you can see it, so it's popped up there. This is basically the GPS of where on the drive we are looking at this point. So it says right here that we're looking at the ASCII drive, disk image, C, documents and settings, RIC, application data. And after that, you can see that right there it says PS, that's the physical sector, LS is the logical sector, CL is the cluster, SO sector offset. So we can find out exactly where we are, not only in the logical file system, but on the hard drive itself. Depending on how you're looking at this data, what you need to know, both can be helpful. So index and keyword search is one of the first things you can do. EnCase can index the whole drive for you, and then you can search it after the fact much quicker. Depending on what kind of investigation you're going to be doing, if you only have to look for a few things, I don't usually index it. It's just going to be a quick, I just want to see if this is on there and then close it out. But if you're going to be looking at this a lot and have a lot of keywords and have people coming back to you often, indexing it will definitely make your life easier in the long run. But it does take almost a day sometimes for it to index initially.
What kind of size is the image, is the index relative to the size of the disk image you've done? Pretty
big.
Okay.
I don't know off the top of my head. I think
I'm sure it varies too with the composition.
Yeah, exactly. I think the last one I did was like an 80 gig drive and a 40 gig index. Mm-hmm. So it was, I can only fit one on my actual computer at a time. Mm-hmm. So I don't do it often. The other thing you're going to do is set up keywords. And right here is keyword search options. And EnCase does have the ability to search by default ANSI Latin 1, just regular text. It can also do Unicode if you're going to do stuff that may have multilingual support or be using Unicode. And the best one, in my opinion, is grep. You can grep stuff within EnCase, which makes this a lot better searching than most other ones you can do. So once we have our keywords set, maybe our drive's indexed, we get to the search box. Basically, this is where we're going to get up all the things that we want EnCase to do. It's going to take a while to go through all the steps. Basically, when I get a drive, I will get to this stage, and I'll select some options. I'll hit go, and then I'll basically see it tomorrow. At this phase, I'm just going to go over some stuff on the slides coming up, but this is a preview of what we're going to see. So one thing we're going to do is we're going to verify the file signatures. I'll tell you about that more in a minute. When we're actually searching, we can check here if we want to search entry Slack. So this will look for the keywords not just logically on the drive of where the files are that you can see in Windows or Linux or whatever it is, but also in files that have been overridden or deleted or partially overridden, things like that. The next one is you want to undelete entries before searching. Basically what this one does is if you have files that have been deleted and you're searching for, let's say, an email address, and you do not undelete it first, and this is a fragmented file, so part of it is on this part of the hard drive, part of this part of the hard drive, but the file is not logically completed, it will not find that keyword, even though it does exist. So EnCase will go through and try to put the files back together that it can piece together, and that will make a logical file. So it'll make that email whole again. and through the keyword search, it can now find that keyword that you're looking for. So this is always a good idea, just in general, because you'll get a lot more hits on it. And you can also compute the hash value. This will be, in most cases, you want to do this for every file on the system. This is one of the things that takes a long time to do. So it'll take quite a while, but it'll be worth it in the end if you're looking for a lot of data. It'll help you weed it out in the end. Yes.
What's typically the bottleneck for EnCase? Is it drive throughput?
Yeah, basically everything I've seen is, yeah, I think it can use as much RAM as you give it, so never stop giving it more RAM. And I think just the processor speed alone is just, mine is always hammered, but I'm running it on a laptop. We're still trying to set up a way to get it to work in a more powerful environment. We tried putting it on a server, but it uses a dongle to connect and know that you have access to it. So when we put it in the dongle in the server, when I remote desktop into it, it doesn't recognize the dongle from my remote desktop session. So now we have to VNC into it, which is getting to be a little bit more complicated for sharing it with other users and that kind of thing. So,
have you tried imaging hard drive to like a solid state hard drive to see if that speeds things up?
Not yet, no, but that definitely would help. But the problem with a lot of these is that the data it's looking for, I have on a separate drive. We buy them by bulk, so there's like 20 or 30 drives. Each one of those is an image of the evidence we're looking at. So it's to do that for every single one of them and buy solid state drives for all of this giant inventory of growing drives, it's getting very expensive. So we just basically buy some, what are they, Richard? They're the Western
320 gig Western Digital Caviar Blue.
They're blues, right? Yeah. So just buy those in bulk, and that's what we usually keep your images on.
But on average, EnCase, or sorry, Guidance Software, they want you to get like a system with like dual quad-core CPU, 3 gigahertz something, and like 16 gigs of RAM or more. They're like, yeah, you can throw more RAM at it and more CPU at it, and that'll help.
You can store the images that you're using on like a SAN or something, and that might be a better solution because we're just using the individual drives to keep them physically separated. It's easier if we have to send off to legal or something. They don't fully understand the aspect of a giant managed server or how to access it. So right now, just even though it's not as efficient, it's been working for us just because we're small enough that it hasn't gotten to that scale yet. But definitely thinking about moving that way in the future.
Do you have a refresh time for the hard drives? Your big inventory, do you like power them up once a year to make sure that they don't get stale, stupid, and
We have not, no. And as for how often we refresh them, I've been looking through them. We have an inventory that's a few years old in some cases, and just trying to figure out what the case was and see what it was relevant to. So just based on an assessment of this case was a major deal. We want to hold on to this basically forever, just as long as we have it. Other cases, this was kind of a small thing. We can probably get this drive back. It's no longer relevant. We've resolved this and hasn't come up in like over a year or two. So it's really on a case-by-case basis right now. We don't have a set criteria of what needs to be maintained for 1 year, 2 years, 3 years, 4 years. And it's not a bad idea to test them, but we do have quite a bit of backlog of them. So I haven't gone through and made it a process to do every year.
Yeah, I think our SOC is just coming up on 4 years of actually doing its EnCase analysis in some capacity. So at that, I think hard drives now are basically 3-year warranties. They're not even 5 for the consumer, like Caviar Blues. So, yeah.
Mm. Yeah.
We have, I think, all total, I think we have like 16 people.
16 or 17 people.
Yeah. Like incident handlers, we might have 5, 6.
Are you talking like on a 24-hour rotation or
No, 9 to 5.
business
9 to 5
hours?
business hours.
Yeah.
Mm-hmm.
Gotcha.
Yeah, 3 engineers, 1 person dedicated to intelligence, and 5 people doing incident response, and other types of just wear different hats all the time. So a lot of sharing, caring kind of thing. One of the last things we can do, and we'll show you here, is you can do an internet search, so you can see what the person did or what the computer did. You don't know the user, but the computer did and the internet history and that kind of thing. So I'll get into that in a minute as well. So for signature analysis, EnCase will look at the headers of files if you check this box. And it has a huge database of known file types. And it's going to compare the image, it's going to compare the signature itself with the extension of the file and see if they match or not. So basically, once it does this analysis, it's going to give you 1 of 4 results. Match is good. It means that's what it says it is. Unknown basically means I'm not sure what this is. And I don't know what the extension is either, so I'm at a loss. Alias is the one that I find is the best results. It basically says, I know what the extension is, and I know what the header is, and they don't match. So this header is actually this kind of file, not the one it says it is. And bad signature basically means I'm not sure what's going on here. You might want to look at this as well. So 3 of these 4 cases are things you want to look into and see if they're false positives or just installation files often don't fall into the correct categories. Yes?
How does Encase determine what the file says it is? Is it the file extension?
Yeah, it's looking at it's basically comparing this to the extension, header to extension.
So if something says it's like the .log file, but it looks like it's, not plain text, it's like has an MZ header or something, it'll be like, oh no.
Yeah, here, I'll show you an example in just a second. So just to give you an idea, this is this is just the one small section of all the image types of header files that Encase has built in. So it's using a lot of ones that are out there publicly available. If you have any specific to your company or what you're looking for that you can always add them as well. This is just the starting database. This is out of the box. If you know more, you can definitely add them, and it can find those as well.
So can I hide my super secret data from Encase by putting .jpeg and putting that header in the front, and it would be like, oh, that's JPEG.
Probably.
Okay.
I haven't tried that, but yeah, if you wanted to try making this JPEG header, like this will find text files that start out with the correct characters for a JPEG. But if it's not actually a JPEG, then you might not find it that way.
Or speaking on JPEG specifically, if you want to hide something, append it to the end of it, because the trailing footer is FFD9. Anything after that, when you open it in a reader, it's not rendered. So it will just read until the FFD9. Whatever extra data you put after that is fine.
Same idea of a GIF at the beginning and a jar at the end.
And then the solution for finding that is to run entropy analysis on the files and look for entropy in the files.
So as you were saying before, here's an example of a file. This file here says it's important file.dll, but based on the header analysis, it's actually a JPEG header. And so right here where you see that little star JPEG image, that's Encase telling you this file is aliased to be a JPEG. It's not what it says it was. And right here you can see this is where the file location was from the GPS. It was located in C Windows System32 important file.dll. So this is just one way, basically find low-hanging fruit. I mean, like you said, you can use this, you can abuse this to hide stuff in ways that this stuff will not find. That's when you have to get much more in-depth and everything like that. Luckily, most of the things I'm looking at, people aren't trying to hide stuff from us. But if they were, there are definitely ways you can hide it, but it's extremely difficult to find. So one of the other things you mentioned was hash sets. The NSRL is at NIST. That's the National Software Reference Library. It's a giant download you can get there. I think it was 3 gigs last time I did it. It's literally just hash values. 3 gigs of just hash values, MD5 hash values that you can then import into Encase. And those are all known good files from sites that have been, this basically software that's out there, known and benign. So with that,
every version of Windows, every patch revision of it,
yeah,
everything.
All kinds of obscure software you probably never heard of before.
I think there might be some malware in there actually. They've started splitting out into multiple sets, I think.
Okay, that's good. When I did upload it in there,
Yeah.
yeah, and that's what you do at the next part. When you put it in Encase, basically they suggest you use 2 different categories. You can use as many as you want, but it's easier if you use 2 of known and notable. Known is the files that you know what they are. They're benign, they're not going to hurt anything. Basically it means you can ignore these files. If you have a corporate image, a standard image at your corporation, it's a good idea to image that, get the hash values of every file on there, add that to your known files. That way you can just ignore those right off the bat and save you some time.
Depending on the kind of incident you're investigating though, one interesting thing to do is look for, even if something shows up on a known MD5 sum list, if the system was supposedly patched current, a month ago, but there are known MD5s from a release 3 releases ago, 6 months ago, then maybe somebody has either missed a patch or and fudged it, or deliberately dropped in known vulnerable versions behind the back of the patch management system so that they can get back in. So just knowing that a file is known doesn't necessarily mean that it's what it should be there.
Yeah, you can't always trust the known and not known, but it is definitely a good way to get low-hanging fruit just for day-to-day stuff. It's better than having to look through all the thousands of files on the system. And like we were saying, the same thing with notable files. So we deal a lot with now. Yeah, you have a question?
Do you index the NSRL information? Say you have like 100 MD5 hashes. How do you quickly look at the bot to say, are these on the list, or can you just put these hash sets into Encase and say, whitelist all these?
You can well, you're not going to whitelist it. You're just going to tell it, when you do the hash analysis, it compares it to the library of hash values that it knows. And you can give it a category, and you can give it known, notable. You can give it NSRL if you want to. And from that, you're not telling NCase to ignore these files. It's just telling you that, hey, this matched my hash sets. If you want to make a filter or a condition later on and say, I just want you to not show me anything that you know is known, you can do that. So it gives you another step that you can do to manipulate the data to show you the least amount of stuff possible and make your life easier.
It's probably what part that makes the overnight indexing take so long. Is it checking the hash you found on the hard drive against the NSRL list?
Mm-hmm. Yeah, it does it for every single file on there automatically too when you do the hash lookup. So, for example, this is a file. I made a hash category called kittens. This is notable files, and this particular file showed up in the hash analysis of this computer. If you guys aren't aware, one of the reasons why I use a kitten here is when the police are doing training on child porn cases, it's illegal to possess child porn. They actually don't want to handle it, so they often use kittens as their fake. Yes, you found the child porn on the computer. So that's what we're looking at here, for example. And once again, here's the location. Program files, definitely not porn, sweet kids photography.jpg. So I mentioned before internet history. What NCase will do is it'll look through index.dat and cookies for records of where the person's been. We saw before there was a comprehensive search button. If you don't check that, it's just going to look in the typical logical places where those files will be on the computer. Checking comprehensive means it's going to take a lot longer, but it's going to search all over the hard drive for other remnants and other files that may have existed related to this type of information. So it'll find stuff on old installations of the computer. It'll look on its base, things like maybe deleted or older versions of the software, that kind of thing. And one thing I like about this is that the Internet Explorer records are also the Windows Explorer records. So even if your user's not using IE as their main browser for searching the web, it can give you an idea of what they were navigating to and looking around to on their actual computer. So I find that to be helpful in some of the cases I've worked on before. And I did notice, I looked at the NCase documentation. They mentioned that this works for Internet Explorer, Firefox, Opera, and Safari. I noticed that Chrome was missing. But I haven't had a chance to test and see what it shows you for Chrome. I think it works because it's related to Safari, but I'm not sure. I can't guarantee that right now. So just an example of what we're looking at here for internet history. It actually makes a small database view. This is not looking directly at the files on the computer anymore. We're looking at records. So it found this and organized it in a more presentable way for internet history. Right here, we saw the tree pan before. This is now showing you what browser it came from and what exactly we're looking at. So this is stuff that it got from index.dat, weekly, daily, that kind of thing. And just here's an example of a file that was browsed to by the user. This is a local file, systems, documents and settings, Rick's desktop, groceries.txt file. And here's an example of someone just going on Bing and searching for goat step in Urban Dictionary. Another thing from the internet history is it can try and show you, render the temp files that it was put in temporary internet files. So here's an HTML file, and it's not going to show you all the pictures and all the style and everything like that, but just for the text and some of the context, you can see where the user was going on here, at least partially. And you can get the full records of where they were visiting and try to figure out what that means, and maybe you can find the temp files for it, try to coordinate what's going on there. And just so you can see, this is in temporary internet files of where this file was found. So another thing you can do, again, we'll do this based on the signatures, is carve files from unallocated space. We'll search for the file headers, and we'll try to see if we can figure out what files used to be on there, because they're not going to be on the registry, they're not going to be registered in Windows or anything like that anymore. We'll just see if we can find headers and see if anything matches them. So I'm doing this with JPEGs because they're easier for presentation. You can do this with any kind of file. You might want to do this with executables or other things like that if you're looking for a malware case. It all depends on what you're looking for. So looking here, this is the search expression. This is the exact same thing from the header we saw earlier for JPEG files. It's just a hex of FFD8, FF, and then either E0 or EE. And we always have to use grep when we're doing hex searches in NCase. And actually, right here is a gallery view of all the JPEGs that it found, just in unallocated space on the system. And actually, I was going to make this demo, there it is, unallocated clusters. I was going to make this a live demo of NCase. I made a fake hard drive for showing this to everybody. But I didn't wipe it first. And so the files I found on this were not the ones that I put on there. This is actually stuff from the previous user of this computer. And so I also found some corporate information, corporate data, so just in case I didn't want to have any spillage, so that's why you're getting the PowerPoint presentation instead of the actual live NCase demo.
Can you zoom in on any
No, I cannot. It's preset. Which one did you want me to zoom in on?
The one next to me.
I know, yeah.
Weren't you in the Navy? He wants to go back and see the butt.
No, not that one.
You have a question?
Is Blackpool files on alternate data streams?
Yes.
Richard says yes.
Yeah, I mean, it's just another, an alternate data stream is just another piece of data that's under the same name, but like a different way to get at it. So it'll still see that data. It's just another data attribute in the
Through
file.
the unallocated search or through the normal file search?
It should still find it.
In either case.
Yeah, because
If
if there's
the-
still
yeah.
references in the NTFS, like B-tree file system structure stuff, even if it's not being referenced to either NCase, if it's not being referenced to still, NCase can find that kind of structure in the MFT and still hunt it out on the file system.
Yeah, so as long as the file's not encrypted in some way, it's gonna have the correct header. It should be able to find it. So here's just an example, more Allen-headed clusters. This is what we're looking at. As we saw there, this is an exact match for the search expression. So this is what the JPEG header is that it found. Just looking right here, this is the area of the unallocated cluster that it found it in. Does anyone know what that PK means? Yeah, exactly. So right around the same place as this JPEG header, there's a header for a zip file, and it also says ppt/media image 84 JPEG. So it's possible that this was a JPEG file that was part of PowerPoint presentation that was in the zip file somewhere. So that's the kind of thing you can figure out with looking at headers and that type of information. Just another quick thing. In this particular JPEG, it was carved out of unallocated space, but you can see at the bottom here it was incomplete. So this file was overridden on the end. It still is able to process what it knows, and sometimes this is enough. Sometimes it's not, depending if you need the full file or just part of it, but you might be left with part of the file, and that might be better than nothing. So just keep that in mind, that you may not find everything if you're carving stuff out of space. It might only half exist at this point. So there's a module you can get with NCase as well. We have it at work. It's called the EDS module, and it basically is there to help you with some encryption and passwords. So I believe I looked up to see what it was doing. I think it's using the Landman hash hack basically for Windows XP on simple passwords. So once again, it's looking at records, not exactly at the data. But here you can see it was able to pick apart one of the passwords, a very easy password, the ASLI. Able to pick that out, and now we know what it is. So I don't think it's going to crack anything too complicated, but it can get some of the basic stuff for you, pretty much without doing any extra effort, which can come in handy sometimes. And like I mentioned before, there's also NScripts. These, you can get them from Guidance Software's website. That's the company that makes NCase. There are others out on the internet. I looked around. I didn't find too many, but if anyone knows any good repositories, please let me know. And if you do know the NScript language, you can make your own. It's definitely possible if you know what you're looking for. Just make exactly what you need. So built in with NCase is one of the initialized case scripts. I run this one most of the time when I'm looking at drives. And it's going to give you information, all kinds of just basic stuff from the registry. Here it is. This is basically what you set. You're going to do it for Windows in this case, but they do have initializers for Mac and Linux as well, so they didn't forget about them. And when you run it, it lets you know what you want to search for, and just give you, basically it's going to search the registry for all this information and just display it to you in kind of like a little report. So here is what the report looks like. They're not big on formatting and making it pretty, but the data is there. Usually you want to export this to Word and print it up there, make it have your company logo on it, that kind of thing. So from the registry, it tells us relatively easily that the owner of this computer is Rick Astley for Never Gonna Give Incorporated. And also will tell us things like the installation date of when Windows was installed in this. So that can be relevant if you're trying to figure out something happened on this system at X date. If the system was re-imaged after that, if you can trust this date. Sometimes you can't. These can be fudged, but if you're just talking about typical users being silly on the internet, they're probably not going to be able to change this kind of thing. It also says the last time this computer was shut down, so you know if like IT came over and gave it to you and said, here it is, I didn't touch it, and you can see that they had it for 4 days and it was shut down last during that 4 days, they might not be telling you the truth. Something like that.
Does it calculate that based upon the latest file it's seen, or is
I think it's looking.
Registry key that says,
Yeah.
for clean shutdowns.
I know that I think ntuser.dat is written to when you log off a system, so you can look at that file to figure out the last time a particular user logged off. It's looking at things like that. Another Nscript that I like to use sometimes is for USB devices. This is one I found on the Ncase repository, written by Brian Jones. And basically, what it's doing is looking through the registry again for any kind of references of USB thumb drives or anything else that may have been connected to the system in the past. So again, this will give you a small report. So there's our script. And after it's run, it'll tell you exactly which thumb drives have been connected to this computer in the past, and even the serial numbers that are in the registry for it. So if you have to collect evidence from a particular case or site, this is a good way to figure out what else you may have missed or what else may be related to it. Similar is right there, it'll show you this is the last time this particular drive was written to. In this case, it's 3/13/2013. So if that's in the time window you're looking for, this might be a relevant thumb drive for you to track down and figure out what else is on there. So as you mentioned, another thing you might want to do is look for encrypted data. A script I use for that is called the Encrypted Data Finder. It is written by one of the guys at Ncase. It's one of the Nscripts are usually free once you have the login account and all that stuff. These are all free to download on their website. This one is basically looking through files for entropy and trying to figure out, is this file what it says it is? Is it is it basically evenly distributed hex values between 00 and FF? And based on that, it takes a best guess on whether or not it thinks this has a pretended, like what chance this is being an encrypted file. So here's an example on this drive, looking at this Nscript. It found the groceries.txt file that we showed earlier, and just based on looking at what it found, it was an 83% chance that this is an encrypted file. And so right there we can see this is the one, the desktop groceries.txt. And looking at the text of the file itself, this is definitely not your typical text file. This is not English readable, human readable text. So it's definitely onto something with this particular file. And one last place that we can look just to see what was going on with the system recently is the recent files. There's a list of files right there in Recents, the one that pops up when you have the start button. And it basically has links to all the files that you've used recently. So in this case, we can see that the groceries.txt file was recently used by this user. Additionally, it'll also show you links to drives that may not be connected any longer. So this was recently connected to an X drive on this system, which I can tell you doesn't exist in the CD-ROM, external media that's connected to the system. So it may be related to that as well. And so now we think that this groceries.txt file is encrypted. And we also know there's a volume X there, which may be mounting an encrypted volume in something like TrueCrypt. So we can copy this file out of Ncase, because Ncase can't get past TrueCrypt, but TrueCrypt is free, so we can download it and play with it outside of Ncase as well. If we copy the file, it asks us how we want to copy it. And we only want to copy the logical data. We don't really care in this case about the slack or what else is on there. That's not really relevant to this. We just want to know what the user sees when they play with this file. So we can copy it out of Ncase as a logical file. And I do have that file as well in TrueCrypt. And let's see. We can mount it. And now it does want a password, but we did see earlier in the password section that there was an easy user password that we can just try that and hope it works. Oops. And it works. So see here, there we go. And now we can see there are some files on there. So nothing too crazy, it's just some information.
Rickroll.
Yep. There you go. So can I hear that? What'd you say? I'm good. All right. So that's basically just a quick, easy demo of what you can do with Ncase. Some basics, nothing too fancy. Questions?
What are your forensics options against full disk encryption?
We're lucky in that the only ones I'm looking at are drives that we've encrypted. So we have the ability to unencrypt those at the admin level. If you're like law enforcement or somewhere like that, it's much harder. You're probably going to have to try to get it out of the user or do something, see if they can find it written down somewhere to post it on the keyboard, that kind of stuff. I'm not as big as encryption? PW Cracker, someone else might know a little more than me.
So we started adding encrypted files to the Crack Me If You Can contest last year, and we picked a whole bunch of different formats that people might actually use. A Mac, I think it's DMG files, a TrueCrypt volume, a couple of TrueCrypt volumes, things like that. And basically for the majority of encrypted file containers out there, like full disk encryption, things like that, there are by now ways to try to do brute force or intelligent password guessing. And it basically just boils down to trying to guess a password on a big container file instead of a little password hash, with all the same caveats and factors to it. If it's a weak kind of encryption, then your odds are better. But most of the full disk stuff isn't poor encryption, so it's down to if the user chose a crappy password. Like, you can still crack a TrueCrypt volume if you can recover the password else some other way, or if the password is Apple, but if the password for a TrueCrypt volume is a 20-character alphanumeric special character random string, good luck. But it all boils down to what is what container file type you're talking about, and then anything you can guess about the length or character set that the target used. And most often, as in the case of what he did, the best thing to do is crack every other password you can find for that same human, and then try to find a pattern of, oh, they reused this or something, so try those.
Are you saying we shouldn't reuse passwords?
Oh my gosh, this is news.
When I went to an actual Encase training that they gave us, and they mentioned one of the last days, they said, and TrueCrypt, basically if you run in TrueCrypt, you're screwed. There wasn't a whole lot they could offer besides what you said, like trying to find ways around getting the password without actually straight up just cracking it. Mostly because it's free and it's really easy to use and hide what you're doing on the system. I mean, we were able to find the encrypted volume with looking at the entropy, but even with that, we're just guessing that groceries.txt file was TrueCrypt encrypted. We don't know that for sure. We just kind of took that leap, and in this case, I made it, so I know it was right. But you're not going to have that luxury when you find that out in the wild.
Yeah, some encrypted container files have tells, like they have a header that says I am a so-and-so. But others, yeah, it's completely opaque unless you have the passphrase.
And I think TrueCrypt also lets you have two passwords. I think there's like a password that you're willing to give up to someone else and let them think they broke into it. And then there's a real password that gets the really the juicy stuff that's even further encrypted in the same exact volume. So you might get one password and not get the other and not even know.
Yeah.
You can also use key files too.
Yeah, exactly.
And the tells to look for, if you think you may have a TrueCrypt volume, well, if the unencrypted part of the computer has the TrueCrypt software installed, it's probably TrueCrypt.
Mm-hmm.
The other thing about the told to passphrase thing, somebody pointed out that while that sounds great and everybody is like, awesome, I'm going to make myself a super secret passphrase and then a bogus one that I'm going to tell the investigators so they don't have to break my fingers. Well, the investigators are going to say, none of the files in this fake volume have been touched since 2008 when you installed this machine. So that's not the real passphrase. We're going to go take a home trip to Home Depot and then we'll be back and you're going to tell us the other passphrase. What's that? Yeah, sure. If you keep your bogus evidence up to date,
Just let your mom reach out.
Yeah, the question? Yeah.
Oh, go ahead.
Let's say another technique that you can use for cracking the TrueCrypt volumes is just if you have the live system, strings the memory down, or strings of the live memory.
Yeah, that can work. What I'm doing here, we don't usually have that, but yeah, if you did, that would be another place to look for it as well.
I think they actually just changed TrueCrypt so that it intelligently zeroes out your password after you enter it now. So that doesn't
Yeah, well, if the crypt software is smart, it'll blow away the password after it's used it to unlock the key. But that decryption key can probably still be recovered from memory. So you may never get the guy's passphrase, but you might figure out the actual encryption key for the TrueCrypt volume or the leak ES volume.
And
that was how the cold boot stuff worked. They were looking for the whatever the math that you do for AES or RSA.
And legally, there's some debate over how to get a password because they can demand that you give them something that you have, like a physical key to a lock. You're required to hand that over, but you don't have to incriminate yourself. So information in your head, they're not the same way as I have to hand this over to the police. So it is a key, but it's a mental key, so it falls both under, you don't have to give this up, it's in your head, and you have to give this up, it's a key to a volume we need to get access to. So they're still working on that in the courts of what they can and can't require you to hand over, and what the penalties are of not doing that. So, yes?
So, are you familiar with the tool Scalpel? Like
No.
it's inside of files to find other, like, it looks for the magic numbers of other files inside of other files, like when they were coming with the example earlier with the JPEG, where you put like a jar on the end or something.
Okay, yeah.
Does Encase have a capability like that, or do you ever actually run into a need for doing something like that?
I have not, no. I usually do this for malware analysis, so I'm looking for signs of infection, that kind of thing.
Okay.
I don't really get too much into the weeds of people that are trying to thwart me. If I did, they have a pretty good chance of doing it. I got to learn a little bit more before I get that far, but yeah, that's the kind of stuff I want to learn even further.
How much of the process that you went through changes if you're dealing with a Unix or a Mac system versus Windows?
The basic process is about the same. It just depends on what you're looking for. I mean, you have to tailor it to the system you have, the information you know, and the information you're trying to get. So the basics will be about the same no matter which one, but the specifics will change depending on what you're looking for.
So the file tree and everything else like that are organized pretty much?
Yeah, it's basically about the same. That's how Encase looks. It's going to display that data to you in that way. I think we tried this on a Linux system a few months ago, and Encase 6 did not like the Linux file format, but they updated it in Encase 7. I was trying to show you Encase 7, but I'm still learning it myself. It's kind of like when people went from Windows XP to Vista. It was a very steep learning curve, and they changed everything. Nothing's in the place it used to be. So this is what I'm familiar with, and 7 can do more, but it requires a lot more TLC for right now for me to figure out where exactly everything went.
That's what you're certified in too.
Yeah, I'm certified in 6, not 7, so that helps.
Thank you.
Sure.